Good morning, guys. This is Donald Abraham. My register number is URKSFDCS041. Today, I'm here to tell you something about queue and circular queue. It's an array implementation of circular queue and queue. In my previous video, I have told you about stack data structure, and this is now queue data structure. So, first of all, I'm going to explain you some queue. Okay, so this is a class queue. I'm creating a constructor like I did in stack, initializing the capacity, and then in queue function C. So basically in queue we have two pointers like in front and rear. Okay, so if the rear is equal to size of element, then it's sure that the queue is full because there's no such no more elements to be inserted. And we insert from rear and dequeue from back, means delete from back, front, and enqueue from rear. Okay, so I'm inserting, so I have to do it from the rear. So I'm just increasing the rear pointer and putting a value on that array index. Okay, so dequeue, if f equal to r, means the stack queue is empty because both the pointers are at same position. So then I'm increasing the front pointer so as to update the size of the queue, and I'm returning the value at the queue. Okay, I'm displaying similar way front to rear, and then and created a switch case menu driven program so as to make it more good its display and all. So in case when I'm in queuing, case 2 I'm dequeuing, in case 3 I'm displaying the elements, and in case 4 I'm breaking the loop. Okay, so let's see. And save a circular queue means basically what happens is that if we delete an element in queue, okay, so front got updated, so the value just behind the front, it's still empty. We can't update, we can't fill any value in that position. So to go around this problem, to solve this problem, we have one more data structure known as circular queue. So what happens is that if we update front, okay, so if rear is at its max position, and if we are inserting elements, so rear goes back to the same position where front was earlier before deleting. So it will insert the element at the empty space that front has left. So in this way we are utilizing the space capacity of the array, and we are not wasting the space so as to make it more efficient. Okay, so circular queue, same class circular queue, displaying the array and front, rear, and size of the circular queue. Okay, so in this constructor I am doing the same, initializing the capacity. Enqueuing is enqueuing and all is the same. See, if front equal to 0 and rear equal to size of capacity minus 1, or front equal to rear plus 1, means if it's like this, if the rear has gone again back to the front, if on adding 1 it's again going back to the front, means queue is overflow, so we can't uh, insert values in that. Okay, so if a front equal to minus 1 means it's totally empty, so we are initializing the front and rear to 0, and then we are inserting a value at rear. Okay, else if it's full, then I'm taking back the rear pointer to front, means it going back to the 0 position, and then we are inserting the value. Okay, so same was in the dequeue, means pop. So in dequeue, queue overflow I'm doing because if front is equal to minus 1, because we can't pop anything from the empty circular queue. Okay, so if front equal to rear, means then also it's the last element left in the circular queue, so I'm initializing both to minus 1, and then I am dequeuing the value. Okay, so in display, same, just running a loop, and I'm printing the values. Okay, so in the main function again I'm doing the menu driven program, and I'm doing the capacity and passing it to the constructor to initialize the value, and in case when I'm inserting value, in case 2 I'm deleting value, I'm just calling the functions that I've created upside up with the help of q1 object. Okay, and then in case 3 I'm displaying the value, in case 4 I'm breaking the value. So let's see how it works, guys. Like I want to enqueue one element, I've inserted 1, again I want to do 2, again I want to do 3, again I want to do 4. Now it won't accept because the queue is full, so it will say the queue overflow. Okay, so now I'm deleting element, so delete element is 1. So if I'm now inserting, it should insert the value 5. See, there's no such message that queue overflow, because as soon as there's one empty space created in the beginning, it's already gone there. So if you display the elements, see this, I've inserted 1 2 3 4, I've inserted in ascending order, now it's giving in descending order. So this was the basic concept of circular queue. And if I'm going to queue, like I'm doing a 4 1 in q1, Again I'm inserting element 2, again I'm inserting element 3, and again I'm inserting element 4. Then when I will insert element 5, it will say q is 4. Okay, so if I will delete also, then it will say q is empty, the pop value is this, so it will give some garbage error because there's nothing in this there. So if I'm now in queuing 1 2 3, okay, now if I'm displaying, it will show me the values. Okay, so these were the basic functionalities of queue and circular queue. Hope you liked my video. Hope it was very beneficial for you, and we'll be coming back with some more exciting videos. Thank you for watching me.